Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with engineering mechanics in the topic of equilibrium of rigid bodies. So the problem is determine the support reactions of the beam shown in figure. So the beam is given, that is simply supported. So one end is fixed and the other is roller support. So now we having the point loads, that is 6 kilonewton. Then it's a vertical force. Then inclined force 60 degree to the horizontal, that is 8 kilonewton. Then a point load is 10 kilonewton at the angle of 45 degree. Okay, so now we can use the equilibrium equation. So for the equilibrium equation we know sigma h, so that is summation of horizontal force equal to 0, then summation of vertical force equal to 0, then summation of moment equal to 0. So this is the equilibrium condition. So we are taking, so the horizontal force, the maximum in the H, A, the horizontal force, then the forces is reactions, that is VA plus VB, and another for vertical forces, then sum of moment about A. So moment about A is equal to 0. So we can take the moment about in this A point. Okay, so using this formula we can easily find out what is the vertical support reactions, that is horizontal force, then VA and VB. Okay, so first of all, the inclined forces we have to resolve in the two components, that is vertical force as well as horizontal force. Okay, so now we can resolve. So this is the beam. So now here VA. So here is the fixed support. So here we can take the VA and HA. Okay, so here the roller support. So now we having only the VB. Okay, so next thing is the 6 kilonewton. So that is 6 kilonewton is a vertical force. So this 8 kilonewton inclined force is converted into horizontal force as well as vertical force, as well as 10 kilonewton inclined force also we can convert into horizontal and vertical. So here we can take 8 sine 60 degree. Okay, likewise here we can take 8 cos 60 degree. Okay, so likewise we can take the 10 kilonewton force over here. So here we can take 10 sine 45 degree. Here the direction will be 10 cos 45 degree. Okay, so this is the beam diagram. So now we can applying the this equilibrium equations. Okay, so now the first equilibrium equation, sum of horizontal force equal to 0. So now summation of horizontal force equal to 0. Here the horizontal force HA is there. So this HA is in negative direction. Okay, so if case this is going this direction is a positive, then this direction is negative. Okay, so now we can take minus HA. Okay, so again the horizontal force 8 cos 60 is there. So here it goes in this direction, so we can put minus. Okay, so minus 8 cos 60 degree. Here the 10 cos 45 is going forward direction. Now we can take plus 10 cos 45 degree equal to 0. Okay, so here we can take HA equal to, so this is going that side, so that is positive 8 cos 60 degree, then minus 10 cos 45 degree. Okay, so we can multiply it by minus. So now HA equal to minus 8 cos 60 degree. So we can multiply it by minus in both sides. So here plus cos 45 degree. Okay, so now HA will be HA equal to 3.07 kilonewton. So this is one of the support reaction. Okay, so next thing is we can find the sum of vertical force equal to 0. So here sum of vertical force equal to 0. So here we can take, so the upward force will be positive, then downward force will be negative. Okay, so upward forces VA plus VB. So minus downward forces 8 kilonewton is there, sorry 6 kilonewton is there, again minus 8 sine 60 degree is there, again minus 10 sine 60 degree is there, equal to 0. So now we can solve VA plus VB equal to, so these terms going that side, that is 6 plus 8 sine 60 degree, again plus 10 sine 60 degree. Okay, so now VA plus VB equal to 20 kilonewton. Okay, so now we can go for applying third step, that is sum of moment equal to 0. Okay, so now we can take the moment about A. Okay, so moment about A, so we having the force, that is 6 into distance is 2 meter. Okay, this is for the clockwise direction. So if case the force is clockwise direction, we go for positive value. So if case go for negative direction, that will be in the anti-clockwise direction, that will be negative. Okay, so this is clockwise direction, and 8 also in the clockwise direction. Okay, so now we can take plus 8 sine 60 into, so the total distance will be 3.5. okay, so 3.5, again we having the force, again plus 10 sine 45 degree into the total distance will be 6.5. Again it having the anti-clockwise force of VB, so minus VB into the total length will be 7. Okay, equal to 0. So solving this, we got the value of VB. So here the only unknown is VB. So the VB value will be 11.47 kilonewton. Okay, so now we can substitute the VB value in this equation. We got the value of VA equal to, VA plus VB equal to 20. So now VB value is 11 point, VA equal to plus VB value is 11.74 equal to 20. So here VA we can find out, VA equal to 8.26 kilonewton. Okay, so these are all the support reactions, that is VA, then VB and HA. Okay, so VA, VB and HA is the support reaction. So this is a method we can solve the problem. Again, we'll see next video. Thank you.